afternoon to the talk, and I welcome Honorable Professor Electrical Engineering, IIT Bombay, Honorable Vice President, Dean Sir, PGI, Madam Donde Madam, who has come all the way from Bombay to educate us on peace and movement disorder. This was the great vision from right from the days of Sarvapalli Radhakrishnan, that teacher cannot be a teacher unless he is a researcher. And the same ethos and values are carried even today. We have in the Maharashtra University of Health Sciences, Lieutenant General Madhuri Kanekar Madam, DVSN, VSN, AVSN, and she is on board of many of the institutions, including PM Science Congress. She had vision that we must grow, and we should not only grow in medical, but we should encompass our knowledge in different technologies and use the medical knowledge to grow the other sciences and take their knowledge to science. And we are lucky that we have got 7 MOUs with IIT Bombay, headed by many of the institutions. We are working hand to hand, but we want to connect heart to heart. And that means a lot of things to us that Sir has come all the way from Mumbai to educate us and to guide us how to grow there. And Dr. Datta Gupta Sir has got so much to done for the country, and this we can't do. I have got a background of FMC and Army. I was surprised that Sir is advisor to US Army, Indian Armed Forces, Japan Armed Forces, Australian Armed Forces, with German Armed Forces. He has lent his knowledge for the betterment of battlefield, and last but not the least, the ethical cause of democracy worldwide. Moreover, Sir has got the training and special interest in terahertz spectroscopy, which is now getting huge application in medical science. Wireless power transfer devices, silicon photomultiplier devices, and mobile green hybrid power transformation. Sir can do a lot for the heart patients, micro batteries, regeneration, and lot many things. We have got lot of things to learn from you, sir, and we are very, very lucky to have kindly joined us to bless the occasion. I request sir to kindly say a few words on the matter. Moreover, we are too blessed that it is the technology day the day before. Thank you, sir. Thank you very much for having invited us here. So I wish to have this interaction grow. Actually, Dr. Kanekar Madam visited IIT Bombay. That time we're very happy that one door has opened for us to interact with the community, and especially because we want to spread the knowledge in Maharashtra in such a way that it is beneficial both from the medical side as well as from the engineering side. So I always tell my students that technically your work has to be good, but what are you also doing for the society? And of course, you cannot compete with doctors, but they are saving lives every day. But we try to bring some knowledge, and it is our job also to see how it is. So the first thing we see is we have to learn each other's language. We're almost learning a new language for us, and to see that whether actually whatever things we are saying will work in the field, well, actually, but not just in the laboratory. So this has been the main drive, and where we can really contribute knowledge which our student, which attended academic research with process.
biosciences. I myself in electronics engineering. So the main thing is, can we capture this knowledge? How can we make better sense of? The knowledge is there, data is there, already there. And we need people like Madam to tell us what it means, how we should. Maybe we can make some additional input, can contribute. But again, firmly tied to the local base. I was very happy to know that 400
colleges we have.
and we work with, so sometimes we are accused of taking the ivory tower and telling people that how wonderful we are. So that is actually not the way. So we have been working with government polytechnic, right? And many other polytechnics. The idea there is that that is our feeder state. And where those people, they will go up to any. So that may be a limited vision, but it still requires reaching out to people, not just taking the idea. Beautiful campus. I like to invite all of you there, especially Madam. Please come sometimes to us. Right? So this is very much required. That's why we are here today. Without further ado, I will begin by being gracious host to us, and I will step in.
Hello, a very good afternoon to all of you. Thank you for inviting us to this. That's a very beautiful campus. So yeah. So next slide. Sir, okay, so I'll be briefly sharing about my work, which we are doing in society movement. So basically, what we work on is what is called as microarrays. So many of you may not be familiar to it. So I'll be taking through the steps of microarray. So basically, I am an electronics engineer, and then I became a data analyst. But today, I'll be taking the data analysis part less and medicine part more, because according to audience, I have to schedule design the presentation. So basically, the highlights of the presentation will be first my work for 2 different diseases using microarrays. Then the possibility of using microarrays for Parkinson's. I just found the paper a couple of days back. Okay, so basically this is this will be better. Yeah. So this is how a microarray looks like. Okay. So I believe many of you must have seen microscope slide, small slide. So it's of standard dimensions, 75 mm by 25 mm. Thickness is like maybe an order of a few millimeters. Now, so why this is important? So you, I don't know whether it is visible. You will be able to see some pores in it. Okay, this is similar to the design of the ball. It is divided blocks and some pores are there. So what happens? So basic what we can think of a disease is we go for blood test. So what is the blood test basically? We take the blood and then we mix it with a chemical which is like a probe. Like for example, like litmus test, we do it. Imagine doing these experiments or assays, as you call it in biology, in order of 1,000 or more. Like we had chips of 45,000 parallel assays together. Imagine the amount of chemicals it will save and amount of time it will save. So that's where microarrays come into the picture. So this is the basics of microarray. Also, it is based on principle of hybridization. Okay, so there is a probe and there is a subject. Subject will be blood serum. Like you must have heard that the Serum Institute of Technology, Serum Institute of India. So blood serum is used so that because it contains a lot of details in the body that are produced in the body. So that's why we use blood serum. And so next, what we do, like we take the blood and we dye it in 2 colors. Let's say red and green, because we have imaging system of lasers red and green. So we have to calibrate accordingly. So why it is important is so the other line of the blood serum, which is dyed with the dye, and then it is smeared on the slide. And okay, so basically, just before I come, so what something pairing takes place? ATGC, adenine thymine guanine cytosine, right? Okay, so what happens once you take a microarray, you smear it with serum afterwards, and the dye is there. Okay, so some hybridization takes place. Now, what is on the chip? On the chip is what you call as biological probes or ligands. I have to use biological terms, right? So it's ligands, and there are different types of ligands on the chip. Now, when you react with analyte, some will bind, some will not bind. Sometimes the binding affinity will be stronger, sometimes it will be weaker. So all these things can be probed. Now, how do we probe it? We have a dye to it. Okay, of course, we can see it just like that. Then afterwards, the bio washing with the buffer, we wash it completely. Once it is washed out, then we excite it using lasers. Okay, so we have a system of a company GenePix in our lab. So there we have dual wavelength lasers, one with red, one with green. The hot to red and green signify I'll be covering in the next slide. So what happens when the red laser excites the slide? Only the dyes corresponding to red color will flourish. Everything else will be dark. So with that, if you image this, you will get an idea of what is the kind of hybridization. See, I know I have a chip. I know where I put chemicals on my chip, the ligands. Now, if I know whichever ones have shown some fluorescence, then I can tell. Okay, for example, let's say these are the bulbs. Imagine they are microwaves. Let's say only 3 of them are lit. So you will know which 3 switches are on. It's very similar to that. Telling a very layman's level. Next one. Yeah. So basically, so I did. So I'm a data analyst person. I did for 2 different sets of microarrays. One were auto antibody microarray, which are useful for Parkinson's, and then there were peptide microarrays, which were used for guess what the most hot topic nowadays, COVID. Okay. So on auto antibody microarray, what is there? Self antigens are there, and the self antigens why I have highlighted them. They will only tell the molecular basis of a disease. See, when you get a disease as compared to healthy individual, some proteins will express, some will not express. So some of the self antigens which express, their knowledge can be used in toxicology, that is in making the medicine. So it's always a parallel or a continuous process. So somebody will refer to our paper to make medicine hopefully. Okay, now this is a bit interesting thing, a peptide. Okay, so before coming to peptide, let me. So are you familiar with these things? Immunoglobulin gene, how many? Yes. Okay, so basically, there's a response of IgG and IgA in the body. Okay, so IgA we had in COVID, but so IgA is for a very temporary phase, IgG is for a longer phase. Okay, so these are called control signals. Okay, means this should always be there. Just like in electronic systems, you have LED indicator which is always there. You know, maybe a geyser and all. So even if that is used to check the indication. Okay, then the buffer solutions and glutathione is transferase. So this is used for the quality check of the slide. So here I have mentioned 2 colors, green and red. Green ones is used for quality check of the auto antibody slides. Okay, right now ignore the right part, please. And the red colored dyes are used for getting the expression of the auto antibodies. Okay, green for quality check, red for auto antibody. So unless your chip passes the quality check, do not proceed with it. Okay. So briefly, so what we do, what biology do, let me tell you. Let's say this is a chip. I will smear it with analyte and do washing. And then there are other long biological steps also. So I'll be sharing a couple of papers which you'll have to read for biological processes. Then you dip it in some solution, then you put it inside we have imaging setup where you put it, and then the image comes there. So at that step only you have to do the quality control. Otherwise, there's no use in proceeding. If it is wrong, you can repeat the experiment. See, macros are like very expensive, so and they come with a reusability. Okay, it's not a user through device. So okay, so that is of the auto antibody microarrays. Next, we have peptide microarrays. So you may be knowing that protein is made up of chain of amino acids. So and these are the peptide cores. So I don't remember the 20 amino acids. You know the 20, the 9 are essential. So they are used as building blocks to build a protein. So now can you print all of them on a chip? Very difficult. So what is done is they are printed in overlapping fashions. Okay, let me tell you in a simple way. If let's say one is 5R peptide, it's A, B, C, D, E. The next one will be C, D, E, F, G. Why there is an overlap? Because the continuity has to be seen. You can't have two peptides which are completely not connected with each other. So the slides we used had a very because high overlap of 13 numbers. Because maybe the entire length was small and they could afford to print these many peptides. And if I remember correctly, there were 4,000 ligands on the chip. Okay, so there was quite much flexibility. So you can imagine how small level this is getting performed. One ligand receptacle size is about 100 micrometers. It is that small. And plus the imaging we do, it is of the resolution of 10 micrometer, which means 10 pixels will be used to define one line of it, and 10 by 10 is used to define the entire one spot. Okay, so what peptides is done. Now consider these examples. This is just a random peptides I have written. You will see, you will see this intensity. Okay. So what happens again? Imagine I have excited this slide. Okay, and the green color is shown in these three and not in the first and last. So we call these regions the immunogenic regions. And because they're continuous, from the peptides we can form epitopes. Epitopes are chain of peptides, basically. So far, yeah. Yeah. Okay, this is the epitope. Thank you, sir. Yeah. So this is the epitope. So how it is formed? Take first 15 of it. Now from next one, how many I have to take from next list? 2, right? There's only overlap of 2. So just keep on appending the ones which are continuous, and you form an epitope. So in most of the papers you will see they will talk about epitopes and not peptides much, because epitope is of higher significance. So that's a continuous range. Like the more bigger range you get, the more confident you can be about disease. So saying one peptide somewhere is significant will not make much sense. Okay, so this is the basics. This I think is something very much familiar with you all. So blood, it's what you can say. So you can store serum for longer time, unlike plasma. Okay, so that's why maybe in COVID the serum was given more preference, and then it is centrifuged, and then the yellow liquid coming on top is serum. Okay, so maybe this can we have had collaborations with Kasturba Hospital in Mumbai, then even international collaborations. We had one with Israel also. So what they send patient samples with they send serum. So I understand microRNAs and microRNA scanning are expression technologies not affordable by a lot of institutes. IIT was one of the fortunate institutes to have it. However, serum extraction and the expertise of serum extraction lies with a lot of medical, even I think the nursing institutes will be able to do it. It's not rocket science. So that's why one step of collaboration will take place. Samples of, let's say, Parkinson patient blood you can share with us, and not the blood is serum, and then we have available microRNAs are there, and then analyst maybe like myself will be there. Okay, so that is serum. Okay, so these are 2 of my publications as a co-author, of course. So first one was for the colorectal cancer. Okay, here I had the auto antibody microRNAs. So what we had was 4 controls and 7 disease samples. Actually, we had 8 more disease samples from Israel also. So these were from Indian samples. So, but like it is advised to always compare control of the same. Okay, what do you call a group of patients sharing similar traits? Cohort, yes. Right. So cohort, because there was same cohort. Israel was considered as a separate cohort, so that's where you can do the analysis like that. Okay, then the 2 things we have to basically what we are comparing: control and disease. So the change in the traits of control and disease can be measured using a fold change. Okay, fold change you must have heard, I think. So that is one indicator. So that is dependent on the intensity difference between the luminescence. But again, since there are multiple experiments, the data has to be brought to the same state. Okay, so that is a statistical. Like I don't think I should be going depths of it, but normalized and standardized methods have to be done. So simply extracting the raw data will not give much information unless it is done through proper analysis. Okay, so we found some of the upregulated proteins. I remember if there was Coro 7 or something. So these are the codes of the proteins, so no need to remember them. So so how do I know that my experiment is everything? Like whatever I have given from my experiment is sacrosanct. Okay, it is so obvious unless you have a parallel reaction doing it. So, for example, let's say I told Mr. Dr. Varpanda, he's now PhD. I told him, okay, I found Coro 7. What he did, he took the same samples, he had some samples, he tested them in mass spectrometry. Then he tested other methods, and still Coro 7 showed high significance. So, there is a multiple checking also has to be done. Okay, that was one thing I did, and yeah. Second one was COVID project which we did. Again, because it was very difficult to get samples because of so many things. So we got 6 non-severe and 6 severe samples. And these were used on peptide microarray. Because of COVID, it is suggested you have to do on peptide microarrays. So here we have to standardize the data and some parameters like Z score. Again, as a p-value. P-values are measured statistics. So that we in every statistical paper you see that. Fold change is not considered here, but p-values because we are comparing peptides. Okay, so here, okay, what we found is immunogenic epitopes and significant peptides. So immunogenic ones are the ones with higher intensity. Then simply, if you consider standard microarray, higher intensity ones are immunogenic, they will check for a significance. So 2 tests have to be passed. And for this also we had a paper for the in the Viruses journal under Dr. Arup Acharji was postdoctoral fellow in our lab. Okay, so having said all that now, I discussed about colorectal cancer, then I discussed about COVID. So what are we exactly looking for? That is biomarker. Okay. It will come here. Yeah. Biomarkers, yeah. So biomarkers what we are looking for. It is the indication of a disease. See, you have any disease, and also one thing we have to see is the early onset of the disease. Okay, like you can't build a well when there is fire. So that is important for all these things. COVID early onset. That so we can test the patient beforehand, and then some signs they will show if they are developing Parkinson's maybe. And that's why I chose a paper which shows similar technology. Also, this is this 25-year-old paper, but it has got some 91 citations in less amount of time. So that's a significant thing. Why I did not take the recent papers? They did not explain microarrays that well, and they were not based on microarrays. So they use their data to use maybe some other techniques. So this is very much possible. What that person did is okay. So he had a lot of samples. Now again, finding patient samples in terms of Parkinson's is not a big deal because it's related to age. Okay, it's not let's say colon cancer or something which you have to find that cherry picking. This is something mostly available. You can simply classify age group and get the data. So that's why he got a lot of data, and he has a normalization followed by followed by p values only. Okay, so that's where that's where maybe collaboration thing can come. The Parkinson patients data can be that is the serum can be extracted, and they can be segregated into Parkinson, non-Parkinson people. Then another category you can develop. No Parkinson, some signs of Parkinson, and let's say a person has Parkinson, there also his blood you can draw. Because even a patient has Parkinson, his blood pattern can help us know whether to what proteins are expressed and what can be avoided and all. So that's where the so that's all for my presentation. Yeah, thanks a lot. Anybody having any questions? Anybody? Okay. We'll be doing it. We have got so that's got the PPM. See on that. As per the law. Good. We come to the 5 minutes. And then we evaluate and find the sizable pieces of Parkinson. Parkinson,
Parkinson plus early Parkinson's. We have got we definitely share the serum. Scan. These are knowledge. Second issue is there's the clustering of the Parkinson's siblings. And the younger siblings were 10 years younger. Early Parkinson can be because us. It has lot of problems. But the other micro areas, as far as concerned, it is bigger. So we have got beyond the risk of that. But sir has for yesterday operated a huge factor. Very sparse temperature again. And this will for the large amount of night. The special areas can help us. What was the factors which were there? And we will also try to cluster them together and we come out with the knowledge. You know, always
Like what we are talking about the cohort system. You get to be colorectal cancer. Are there any similarity in the cohort factors concerned with the Parkinson?
Parkinson viruses the paper and we are not working. It's a interviews from other countries. That's why the board we have not yet worked. No, not yet. We have just looked at the. So related to myself. There are other things. But I think the benefit.
There is some friends and second that and
But we should also set the effects of titles. If it is very good, so we have people again many products.
complicated. It's like I'm saying this involving predominantly the right and partially for
Any questions from the question I had?
so
This is a main case. That's what we need actually.
उसको बता दो
This and all people needs the candidates which take and you are with us. Yes, you are with us. Very good. Please come. Come. We come to a very important part that we are looking for, and that is the Parkinson disease and movement disorder. We all know that we are aging fast, and India ages faster than before. And every decade, you will realize census, the elderlies are doubling while neonates are halving. This is the status. I am very sure that in 2031, what we today see octogenarians at only 8 crore of 127 crore population, we will have at least 60. And out of 1 in 10 will have Parkinson's or Parkinson. It starts very early, as I was interacting with Samira Madam. She was saying that it starts very early, very nascent and quiescent as differing the signature. People have got the small problem, missing the counting of the groups and like that. And it debilitates to the extent that people are. We do have methods to prevent the secondary Parkinson's, which are actually toxin induced, the post-infectious, leptogenous, and others. We have the answer, but the care, compassionate care, empathetic look after is the only answer of primary Parkinson's. And I am very sure that the 12 crore people who will have the access will not have the. If we truly dedicate ourselves in capacity, which Madam has really chosen to come with, that it will go a long way in creating the awareness, capacity building, and then after caring lot of people and saving the human dignity. So there is a lot of hope, and the icing on the cake was Chaitanya's presentation. We have to find out the epitopes to identify early and give the institutional therapy and lot of things. It is a great day, and I invite Madam to come to give the presentation. Second issue is Madam is the director of communication of the MD program, and she is very actively working in all the parts in slums and underprivileged area. And I will just say, utter these words, the only way to thank the society is democratize the society. And I always admire it. If you go to the people who don't have access to it, you don't have resources to it, definitely you are spreading the science for its true meaning. I invite Madam and her whole team to guide me. Thank you.
Good afternoon, everyone. At the onset, let me thank the MUSS for giving us this great opportunity to present ourselves and talk about Parkinson's disease, which is really a very unknown disease. There is not much awareness about this condition. So, me and my team is here to talk about our organization and Parkinson's disease. Parkinson's Disease and Movement Disorder Society was founded by Dr. B.S. Singhal, who is a very senior neurologist. He is 90 and still practicing. He started the organization mainly for to create awareness about Parkinson's. The organization was founded in 2001 when there was no awareness at all about Parkinson's. Even today, when you go and you ask how many people have heard about Parkinson's, it's hardly 50% of the people in educated category. So one of the main aim is to create awareness wherever possible. Secondly, to provide free therapy to people with Parkinson's, because once somebody has Parkinson's, there is no cure to it. It is a progressive disease and needs therapy. The importance of therapy is really very critical. So we provide free therapy to in a group format. And the third thing is to improve the quality of life. So we are not into any research or providing any medication or diagnosis or treatment. We provide rehabilitation and see that they improve the quality of life. So we have in our services, we have reached to 19 states, which actually before pandemic, it was 13 states, and during pandemic, we had to close down all the physical centers and go online. One of the advantages was that people from remote areas could join online, smallest places also could join. And we reached to 19 states, and we are still trying to reach out to more and more people through another program which we call Healthy Aging Program, where in the rural and tribal areas there is it's not diagnosed, so people do not know that they have Parkinson's. But with our expertise in working with the senior citizens, we felt that if we go there and start some program for the people, we may be able to find people with Parkinson's and anyway provide a healthy aging program for exercises for body as well as mind. So that is something new that we have recently started. So to go on with Parkinson's disease, I invite Dr. Kshitij. He is our physiotherapist in Nasik Center, and he will take us through Parkinson's disease, what the disease is and what we do for at our center.
Thank you, ma'am. Good evening to one and all. And I'll be just taking you forward towards what Parkinson exactly is. So this is a slow progressive neurological disorder, which is which used to be most common in the age group of 60 and above. But in the recent study, we have found that this disease is found even in young age group, that is called as young onset Parkinson disease. So 10 million people in world right now have Parkinson's, out of which 1 million patients are in India. So mainly this is a disease related to the reduced levels of dopamine, which is in the brain, and we see patients with Parkinson's having signs like tremors, rigidity. They find it difficult to walk, their gait is affected. But the thing is, how does this exactly happen? It is still a big question, and it is still in the stage of research. And some of the environmental factors that we know are the repetitive head injuries, patients with repetitive head injuries, patients who are exposed more to the insecticides and pesticides. Some of the patients who have exposures to metals such as manganese. Then right now we don't have a definite reason to be found, and it is also said that there is some genetic predisposition in many cases, and definitely environmental causes are a big reason. We also see many motor symptoms, such as when you see a patient with Parkinson, you will see uh, his posture in a forward tilt, his head in a forward tilt posture. Then you won't see much of the facial expressions. The facial expressions are mainly blank. Then there is always a lack of arm swinging. You won't find a patient with Parkinson's swinging their arms too much. There is difficulty in dressing, eating, and to carry on the activities of daily living. Patient is always at the risk of developing. Patient is always at the risk of having falls. There are frequent falls, so most of the patients they always need a caregiver at home, and there's always a fear of social protest also in patients. Now, these are the symptoms related to the memory. Patient will face memory problems. Most of the patients complain that they have delusions, sleep problems. The sleep cycle is disturbed. Then constipation is most commonly found in all Parkinson's patients. Uh, the symptoms, these are the symptoms mainly which are not seen, but they definitely affect the quality of life of the patients, and it does affect their family members and the caregivers also. Uh, Going to the diagnosis of the Parkinson's, mainly the symptoms reported by the patients and the thorough clinical assessment done by a neurologist. CT scan, MRI, most of the patients, PET scans are also performed. Right now, TAP scan is helping in many of the cases to diagnose the condition, unless and until the doctor is like unsure about the exact diagnosis. So that scan, that is the dopamine transport scan, which is carried out. Uh, Treatment of Parkinson's, the medical line of treatment, mainly dopamine. The levodopa is the main drug which continues to be given to the patients. And surgical intervention in some cases, definitely by the opinion of a neurosurgeon, deep brain stimulation does helps in many cases. And the rehabilitation services play a very big role in management of Parkinson's, mainly physiotherapy, speech therapy, cognitive therapy, occupational, dance and music therapy has shown very good results when it comes to the mainly the bradykinesia patients. When patients experience slowness of movements, their postural problems, the gait issues, it does helps. Dance and music therapy definitely helps, and diet and nutrition also plays a very vital role along with yoga. At the support group sessions at PDMS, we engage patients in multiple activities such as art therapy, yoga, physiotherapy, cognitive therapy, counseling, and psychotherapy as well, dance and movement therapy, speech therapy, and diet nutrition. Through this, what happens is patient get engaged into multiple activities by which some time they come away from what exactly they are going through. They get a group of good friends coming together. They have some good fun learning sessions also with us. And multidisciplinary therapies in this way right now we are conducting for all the patients. Now, the benefits of group therapy are like I said, when the patient comes to the group session, they don't realize what exactly they are going through. They like come away from Parkinson's. They interact with people who have Parkinson's and make new friends. They share their experiences with others and learn from them as well. And they get motivation and support from others, and they enjoy exercising together. We have planned exercise in such a manner that it would not look exactly like exercises. It looks more like a fun session. We conduct games for them. A small quiz competition is also being arranged. Some brain training activities are being given. So in this way, they get very well engaged into the activity. Physiotherapy it definitely helps in improving the movements which are affected in patients, and mainly we work on the neuromuscular flexibility of the patients. Patient having core muscle problems, balance problems, we train them how to maintain their balance, how to be at the center of gravity, then how to strengthen their weak muscles, and most of the problems they are always a fear of having fall. We also educate them about the fall prevention strategies, how to prevent the falls, and we special emphasis is given to the ergonomics also, like which angle to bend, how to maintain your proper posture, and how your alignment of the spine can be maintained for in a much better manner. Speech therapy, we work mainly on the voice, which is more affected in patients with Parkinson's. The volume of the voice, then the clarity of speech, breathing exercises. It does helps a lot, and facial expressions are also improved when some of the facial exercises are given to specific patients. Patients having swallowing difficulty. There's one more variant in Parkinson's called as PSP, that is progressive supranuclear palsy, in which the patient has completely lost the facial expressions. The gaze also is affected, and in such patients, we have found that this speech therapy, facial exercises have shown very good results. Counseling is mainly done the emotional and the psychological needs of the patients and his families are being looked after, and to work on the social stigma, anger, depression, anxiety. These are the common complaints that, or these are the common things that patients go through. So we definitely work on these things also during the counseling sessions. And diet and nutrition definitely plays a very big role when it comes to Parkinson's. The role of diet is more important, and we plan the timing of the food and medication in such a way that it doesn't affect the patient's activities of daily living. Their food clock and their sleep cycle doesn't get affected. And definitely management of constipation is a big challenge. Most of the patients have this complaint, and we also help them to how to manage constipation problems. Creative therapies is something that we have included in our rehabilitation services, because we have observed that most of the patients are very good at some art. They have some a special out of the box art form. So we take it as a positive thing, and we train them in such a way that they're something that is X factor. We train them to use that special talent in such a way that it helps in dealing with Parkinson's. So creative therapy, fun learning sessions, art and craft. Like in Diwali, we had some lantern making competitions. And patients took that activity very positively, and patients enjoyed it. Dance and movement therapy. Research has shown that dance definitely helps the beats of the music. It definitely helps in improving the movements of the patients, mainly rigidity, bradykinesia, tremors. We address all these conditions through dance and movement therapy. And while doing this, patient gets totally engrossed into that activity. The bits of the music, they pick it up in a very nice manner, and uh, the caregivers are also being trained to take this activity at home, and the patients really enjoy it. Um, Through PDMDS India, we have a reach out program wherein we are reaching out to the patients who have not got good access to the rehabilitation services. On this, I will request Shamila ma'am, please come and guide us. Thank you.
So this is the program that I was talking about, that healthy aging that we have introduced in the rural and tribal areas. So we provide physiotherapy, but like Chitrit said, we do different activities. So it doesn't seem like an exercise. It's more fun, but we have neurophysiotherapists and neuropsychologists who plan these activities. So in the rural and low socio-economic areas, we have these programs, we have group sessions, we have awareness rallies, and through different strategies, we reach out to the people in different areas all over India. Also, we provide training to the ASHA workers, ICDS teachers who have the database of the people of that villages. So we have two main healthy aging programs. One is a program for senior citizens, which is a short program, like a 1 day, 1 or 2 hour program to give information and awareness. And the second program is at the senior residential homes or the old age homes, where we conduct regular sessions for them. So in the awareness program, of course, we talk about the neurological conditions of the elderly. It's not only Parkinson's, but we also educate them on stroke and dementia, because these three are the most commonly seen neurological conditions in the elderly, and give them strategies to effectively manage these conditions. And so these are some of our awareness programs in rural areas, tribal areas. So now we are reaching out more and more to different areas, including the Northeast India, South India. Like districts like Tamenglong, which is supposed to be one of the most backward district in India. We have 6 groups, senior citizens groups happening over there. So in the senior old age homes, what we do is the programs are the exercise program, which is conducted for the residents. Second thing is we train the caregivers. So we conduct the program and we also train the caregivers and or any person from the group. Sometimes it's one of the residents who comes forward, then I can do this. And then we train them to take these exercises and activities for them. If there are any patients with Parkinson's or stroke, then our physiotherapists online guides them. If they are far away, if we don't have a center there, then it's online. And in addition to that, we have noticed through this working at old age homes that the caregivers themselves undergo so much of stress, because they are 24 hours with the residents and they don't have time. They can't give time for themselves or think for themselves. So we have programs in once in 2 months where they don't think, not for their duties, but for their own well-being. So these are the 3 things that we do at the old age homes. Even in Nasik, we have these programs in 2 old age homes where Chitij also goes to conduct the program and train the caregivers. And in many other places, in Pune, we have 8 old age homes. All over India, we have more than 50 old age homes where we conduct these kinds. These are some of the pictures of these old age homes. This is Northeast. In Sikkim, Manipur, Meghalaya, and Nagaland, we have these programs in the Northeast. Also, our organization, Parkinson's, is included in the Persons with Disabilities Act. So our CEO was invited as a consultant to give recommendations for Parkinson's disease. And also, she is on the World Health Organization Committee for Parkinson's from Asia, and as well as on the World Parkinson's Coalition, World Parkinson's Congress. So we are on the international page now, and our program is, so there was this paper published by her, and we are recognized as one of the best programs in the developing countries, because other countries, what we have seen is they have this support group, but the support group is more of a social activity. They come together, chit chat, have tea or whatever. But our program is a rehab program, And it's a multidisciplinary program. So now this program is also being replicated in Kenya as well as in South Africa. So, which we are really proud of, that this program not only all over India, but we are now crossing the boundaries. So, this is about our organization and the work that we are doing, as well as some information about the Parkinson's. If you have any questions, they are open. Thank you very much. That's our motto. Together we move better. So it's a group. Thank you. Thank you.
That's